Welcome. My name is Jerry Soonering, and today we're going to be looking at how can we use a letter to represent the unknown to solve problems. So in this lesson, we're going to be looking at how to solve multi-step problems, and we want our students to understand not only a variable and also how to read through a math word problem and develop strategy. So here are some strategies we want students to understand when working through a math word problem. The first is to read the entire word problem. This may require students to read it several times so that they understand the context of the word problem. Then we want them to think about the word problem. After reading it several times, can they make sense of what the word problem is discussing and talking about? Also, thinking about what are some key information that would be valuable in developing a plan in order to solve the problem straight away. The third is write on the word problem. So this means when understanding what the word problem is about, annotating, underlining, and circling key important information that's going to be very crucial for them to understand what to do. Another option we want students to do is draw a picture. In math, it's very important to see something visual, especially sometimes our students may need something visual for them to guide them to make sense of what the word problem is discussing. And it gives students a more concrete way of learning and understanding the problem. The last is check your answer when you're done. This is very helpful for students to make sense. It requires some time after the word problem and arriving at the answer, but it can help students double check their work to see if everything that they did was correct. In this lesson, we're also going to be looking at variable. Here's the definition of variable. Variable is a symbol which works as a placeholder for an expression or equations that may vary or change. So here's an example that we can show students. We can show them different letters. Here I use the letter M, and we see that 3M is equal to 54. We know we can elaborate and say M is a variable, it is a letter, and when working through the problem, we want to allow students to think about completing the inverse operation to get the variable by itself. Variable is very crucial, so we want students to recognize in this problem that when we see a 3m, it's being multiplied. And when we're trying to get rid of the 3 to have m by itself, we want to divide on both sides to get our answer. In this case, m is equal to 28 once we divide by 3 on both sides. Now we're going to be looking at some examples. So we're going to be looking at this problem, 5x plus 9 equals 74. When working through this problem, I provided a sample example for students to follow and some guidance. On the next slide will be the actual problem we'll be working through, which is the 5x plus 9 equals 74. But showing students an example and how to work through the problem will give them some guidance in how to know what to do first, and second, and third. Now I'm going to go on to the next slide, and we're going to look at how to solve the 5x plus 9 is equal to 74. So when looking at the 5x plus 9 is equal to 74, still following the same format, we want a verbal explanation and written explanation as well. The variable is the last step. To solve for the equation, you first get rid of the plus 9. So here we see in the problem, the x is attached to the 5, and we're going to do that at the last step. We want to have that all by itself. So in order to get rid of this other piece, this plus 9, we're going to do the opposite, the inverse, which is subtract 9 on both sides, which we see in this step. Get rid of the plus 9, do the inverse, which is negative 9 on both sides, so providing a written explanation as well as a representation of how that works. Then we can see this example. And then the last step is to get rid of the 5 from the 5x. Since we see that 5 is being multiplied by x, we do the inverse. Just like here we did to get rid of a positive 9, we subtract 9. Here we see a 5 being multiplied by x, we're going to divide the 5 on both sides. And we get x is equal to 13. We're going to go over two questions. In this problem, we see Leanne needs 120 tiles for an art project. She has 56 tiles. If tiles are sold in boxes of 16, how many more boxes of tiles does Leanne need to buy? Use a letter to represent the unknown in the problem. So in this problem, we can allow students to annotate, read through the problem, and think about what's important information. And from there, we can have them and support them with developing a math equation. On the next slide, I'm going to provide guidance on how we can support students in that process. So we want students to take out some key information. We know that one box is equal to 16 tiles, and we can get that information from underlining, annotating, and highlighting these problems and looking at key information. Helping students identify numbers is a good strategy in deriving information from the math word problem. We also can use the letter B as our variable for boxes. So it helps students to understand that B means boxes, and it would help them understand that I need to find the number of boxes that will help Leanne in the problem. What I set up here is a T-chart, and we set up the problem. We know that she starts out with 56 tiles. She has 56 tiles already. We know that a box contains 16 tiles, and B would be the number of boxes she would need in order to get to 120. And again, 120 is the number of tiles. It's her goal. It's how much she would need for her art project. So when we write out the problem, which is very important because once we have this as our correct process, then we can work through the problem and get to our answer. Here we want students to subtract 56 on both sides, and remember, we want to allow them to think about the variable is always the last thing we need to get rid of, so we do the inverse operation and subtract 56 on both sides. In the next step, we're going to divide 16 on both sides, and from there we would get E is equal to 4. And we can write a little statement on the bottom. Leanne needs to buy 4 boxes of tiles to complete her art project. We're going to look at another question. We know that Gwen pours 236 milliliters of water into Ravi's beaker. Henry pours 189 milliliters of water into Ravi's beaker. Ravi's beaker now contains 800 milliliters of water. How much water was in Ravi's beaker to begin with? So we can allow students to do the same process by annotating, reading the problem, and deriving information from it. On the next slide, I provided a step-by-step and actual visual that will help us with this process. Here, I wrote 3 stages. We know that in the beginning, Ravi had some amount of water in the beaker. Then Gwen put some water in the beaker, and then Henry put water in the beaker, resulting in, at the top of the beaker is 800 milliliters. Here we can say R is Ravi's water, so that we need to know how much Ravi needs, or how much he started out with. And here's the process, still using our steps and problems, and to work through the problem, and here's our solution. Last, we're going to go through our summarization. So when working with students in using how can we use a letter to represent the unknown to solve problems, the letter helps us make sense of the problem, and it also serves as a placeholder in the equation. Hopefully these tricks and guidance will help you and your students with these strategies and looking at similar math word problems and getting to the answer. So hope this was helpful. Have a great day.